In chapters 1 and 2, we were working with degrees. In chapter 3, we're going to work with radians, which is a different way to measure angles. And just a reminder of what 1 degree looks like. Suppose that we have a circle. And we know that the angle formed all the way around would be 360 degrees. So just 1 degree would be a very small angle. So something like this. The measure of this angle is 1 degree. Now we're going to be working with radians. So I'm going to go to another page. Okay, here are some examples of radian measure. Suppose that we have a circle that has a radius of 1. So do you see how this length is 1 and so is this length here? Now if we take that length of 1 and we measure that across this arc, this also has a length of 1. Whenever you can form an angle where the radius and the length of the arc are both 1, then this angle, theta, is 1 radian. So theta is 1 radian. If we wanted to measure an angle of 2 radians, let's go to the second one. We have a radius of 1, and then coming around we have 1 and then 2 of the radii, and then this forms an angle of 2 radians. So here, do you see how the radius has length 1 and then the arc length is 2, so twice the radius. The next circle has a radius of 1, but then if we measure out 3 of those units, do you see how we end up over here? So this angle, theta, is equal to 3 radians. So you can see that 1 radian is much bigger than 1 degree. And then we could go 4 or 5. The next example is if we have a radius of 1, and then if we go around by 6 units. So this would be approximately 1, 2, 3, 4, 5, 6. So theta is equal to 6 radians. Now for this example, I used a radius of 1, but it doesn't have to be a radius of 1 for the circle. You could take a radius of 10. So let's see what happens. So if we go back to the first one, suppose that we have a circle that has radius 10. I'll just put a 0 here. So we have radius of 10. Then if I take a measurement of 10 for the arc length, we would still have a theta is equal to 1 radian. So you see that the angle, the measure of the angle, did not change. For the second one, we could have a radius of 10. And then if we measure out the arc length, that would be 20. And so then theta, you still see the angle has not changed. So even if the circle is larger, smaller, it doesn't matter. Theta will still be, if we look at how this compares, for this one, the first one, do you see how S is equal to 10? S is the length of the arc. The radius is also 10, and then theta is equal to 1 radians. Well, there's a formula that we can use. Theta is equal to S over R, where S is the arc length and R is the radius. And you can see that works for all of these. For the second one, we have 20 is S divided by 10 gives us 2 radians for the measure of that angle. So if we look at the circle in general, do you see how if you're going almost all the way around the circle, if we look at the last example, almost all the way around we have 6 radians. Well, if we go completely around, it ends up that you're going around 2 times pi radians. So if we go completely around the circumference of a unit circle, you have 2 pi radians. Well, does that look kind of familiar? This is if the radius is 1. Well, if you think of the circumference formula for a circle, remember how it's 2 pi times r? So in this case, if the radius is 1, then circumference is 2 times pi. Coming back to section 3.1, so we see that a radian is much larger than a degree. Looking at the definition of a radian, an angle with the vertex at the center of a circle intercepts an arc. We used S to describe the length of the arc on the circle, equal in length to the radius of the circle, has a measure of 1 radian. So let's look at these examples. The first one, we have theta is equal to 2 radians. And the reason why is because we have r for the radius. If we take 2 times r, so 2 of those lengths, then for the arc length, then we have theta is equal to 2. The second one, if we have a radius of r, but we only take the length of half of r, then the theta, the angle, is just equal to half of a radian. The third one, the radius is r. If we go completely around the circle, then the angle is 2 times pi, because the circumference is 2 pi r. So in general, if theta is a central angle of radius r, it intercepts the arc of length s, then the radian measure of theta is equal to s over r. For radians, we're not going to use units. It's just a pure number. So when we're describing radians, we're not using feet or centimeters. It's just radians. So comparing degrees with radians, 360 degrees is the same thing as 2 pi radians. Now, if we divide both sides by 2, do you see how we have 180 is equal to 1/2 of 2 pi, which is the same thing as pi radians. So if 180 degrees is equal to pi radians, then we could say that 1 degree is just pi over 180. And then if we have 1 radian, that's the same thing as 180 degrees divided by pi. So just to make sure you understand that, for the first one here, 1 degree is equal to this. You're just dividing both of these by 180. And then for 1 radian, you're dividing both of these by pi. Now we're going to do some conversions between radians and degrees. And so we're going to multiply a degree measure by pi over 180 to simplify, and then simplify to convert to radians. Or if we have a radian measure and we want to convert it to degrees, then we just multiply by 180 degrees over pi. Since pi radians and 180 degrees are the same measure of the angle. Going on to 3-3. Just a reminder, when you're comparing degrees with radians, 30 degrees is a very small angle, but 30 radians is a very large angle, because remember, a radian is it's just a little bit less than 60 degrees, so 30 of those, you're going to be going around and around quite a few times. Now, when we're writing degrees, you're going to put the degree sign, but when we're writing radians, there are no units. So let's practice going from degrees to radians, and then radians to degrees. If an angle is 0 degrees, then that's the same thing as 0 radians, an approximation. Now, 30 degrees, if I want to convert that to radians, then I would just go 30 degrees times pi over 180, which is equal to pi over 6. So this is pi over 6. Now if you use a calculator, pi divided by 6, you're going to get approximately 0.52. 45 degrees, multiply that by pi over 180, and we get pi over 4 if we simplify that. So this is pi over 4. If you plug that in a calculator, you're going to get 0.79 for an approximation. Third one, if we have pi over 3, we want to convert that to degrees, then I'm going to multiply by 180 degrees over pi. See, the pi's divide out, and so we have 60 degrees. If we plug in pi divided by 3 in the calculator, we'll get 1.05. 90 degrees is how many radians? Well, that would just be 90 degrees. Times pi over 180 equals pi over 2. So the exact is pi over 2, and then the approximation is 1.57. 3.14 is approximately pi, and we know that pi is the same as 180 degrees. And then you can probably figure these out. Multiply 270 degrees by pi over 180. We're going to get 3 pi over 2, which is approximately equal to 4.71. And then 360 degrees, well, that's going around completely, so that's 2 pi, which is approximately 6.28. So the exact values are in terms of pi. The approximations are decimal, approximated to the second decimal place.